Okay, good morning all of you. In today's session, we are going to discuss the pH scale. So at 25 degrees Celsius, pure water has a hydrogen ion concentration of 10 to the power minus 7 mole per liter. Actually, most of the great scientists involved with chemistry were Europeans, and in Europe the standard room temperature is taken as 25 degrees Celsius. So lot of chemical measurements and value calculations are done at 25 degrees Celsius. So at 25 degrees Celsius, pure water has a hydrogen ion concentration of 10 to the power minus 7 mole per liter and OH minus concentration of 10 to the power minus 7 mole per liter. Now, basically, what happens is that at 25 degrees Celsius, the product of hydrogen concentration, we write it like this. You write H plus and put third bracket on either side, and hydroxyl concentration you write OH minus and put third bracket on either side. So the product of H plus and OH minus at 25 degrees Celsius is 10 to the power minus 14. So this concentration of H plus into OH minus is 10 to the power minus 14. This is for 25 degrees Celsius, and this product is called ionic product of water. So this product is known as the ionic product of water. Now, suppose you add some acid to the water. You add some acid to the water. So then what will happen? This H plus will go up and OH minus will go down. But 10 to the power minus 14 will remain the same. Similarly, if you add some OH minus to the water, then this OH minus will go up, H plus will go down, but the product will remain the same. Why? Because the product is related to temperature, and 25 degrees Celsius is the temperature. So if I put more H plus into pure water, that means I am making an acid. If I put OH minus extra into pure water, that means I am making a base. So in a pure water, these are the concentrations of H plus and OH minus. But if it is acid, then this will be lesser and this will be more than 10 to the power minus 7. If it is a base, this will be lesser and this will be more than 10 to the power minus 7. And that is how we do the comparison between acid and base. But there is one problem. This 10 to the power minus 7, or basically such type of powers of 10, they are not very convenient for calculation. So the scientists decided a better option would be to have a scale by which you can convert this into a more measurable value, and that is the pH scale. So according to the pH scale, the pH is minus of the logarithm of the hydrogen concentration. So pH is minus log of H plus. This is the pH scale. So suppose if I am having hydrogen concentration 10 to the power minus 7, so then the pH will be equal to 7. Okay, so pH is minus log of hydrogen concentration. So if the hydrogen concentration is 10 to the power minus 7, then the pH will be equal to 7. Now, what this means is that for pure water, the pH is 7. Now, suppose you are putting more acid into the water, then what will happen? This quantity will go up. If this quantity goes up, the negative logarithm will go down. So that means pH of acid is less than 7. Right? I repeat again. Suppose the pH of pure water we have calculated is 7. Now you are putting acid into the water. So that means this quantity will go up. If this quantity goes up, the negative logarithm of this quantity will go down. I'll just give you one example. Suppose instead of 10 to the power minus 7, suppose if you take 10 to the power minus 4, like you have taken pure water and you have added acid to it. So 10 to the power minus 7 has become 10 to the power minus 4. then the pH will be minus log 10 to the power minus 4, which is 4. So you can see that if you take an acidic solution, the pH value is coming, like in this case it is coming 4, which is lesser than 7. So that means pH equal to 7 is pure water. But if you are talking about acid, pH will be less than 7. And if you are talking about a base, then pH will be greater than 7. So for an acid, pH is less than 7, and for a base, pH is greater than 7. So this is the discussion for today, and based on this I am now giving you the homework question. Okay, next we come to the homework question for today. This is the homework question. The 5 solutions are there: A, B, C, D, E. The pH is 1.8, 7, 8.5, 13 and 5. So these are the 5 A, B, C, D, E, and these are the pH values. You have to classify these 5 as neutral, slightly acidic, strongly acidic, slightly alkaline, strongly alkaline. So these are the 5 solutions. You have to classify them as neutral, slightly acidic, slightly alkaline, strongly alkaline. Just remember that 7 is neutral, so anything very close to 7 is either slightly acidic or slightly alkaline. Anything much lower than 7 is strongly acidic, anything much higher than 7 is strongly alkaline. So this is your only homework question, and we will continue next session. By the way, the deadline for the homework is Wednesday 9 p.m. That will be all by all of you.